Good afternoon everyone, this is Manoj Kumar from the Department of ECE. Today I am here to present a topic on carry look ahead adder. So VHDL modeling of a carry look ahead adder. So the contents are 4-bit, we'll look into 4-bit look at carry look ahead adder and the VHDL program in the data flow style, and the outcome, it is the modeling of a 4-bit CLA. So 4-bit carry look ahead adder. It is an improved version actually of a ripple carry adder. The ripple carry adder, if you see the ripple carry adder, the diagram of that one, for just a 2-bit or also for a 3-bit, if you observe, for a 4-bit ripple carry adder, with the carry in as C in A0, B0, A1, B1, A2, B2, A3 as well as B3, and the carry is C out, and the respective sums are S0, S1, S2 as well as S3. Now for the final carry to be produced, the first bit full adder, it should generate a carry C1. Only then the second one will be evaluated and the second bit carry C2 will be evaluated. Only after getting the C2, the C3 will be evaluated, and finally the C out will be coming. The disadvantage with this one is the delay, because the final carry is dependent on the previous 1-bit full adders. So that is the reason why we will go for a carry look ahead adder. Now, so it is an improved version of the ripple carry adder. So how it is advantages? It generates the carry in of each full adder simultaneously without causing any delay. That is the main point with respect to the carry look ahead adder. That is, the carry of each full adder will be generated without having any delay. So they work by creating 2 signals. There are 2 signals, that is P, that is propagate, the next one is Z, that is generate. So carry propagator, the next one is a carry generator. So the carry propagator is propagated to the next level, whereas the carry generator is used to generate the output carry regardless of the input carry. There is a main reason why the delay will be reduced. So for a 4-bit carry look ahead adder, the first one as seen, it is a propagate, that is P, the next one is generator. So the propagate is A XOR B and the generate is A and B. In addition to that, the carry of each one is given by G plus P into Ci, that is Ci plus 1 is given as Gi plus Pi into Ci. So basing on that, we can calculate C1, C2, C3, C4. C4 is nothing but the C out, that is the carry, and C0 is nothing but the C in, that is the carry of the full adder. So if you see for C1, it is nothing but Z0 plus P0 into C0. So Z is the generating, that is the P is the propagating, which is nothing but Z0 is nothing but A0 into B0. Similarly, P0 is nothing but A0 XOR B0, and C0 is nothing but C in. In a similar way, next one, that is C2. C2 we can get as Z1 plus P1 plus C1. Similarly, C3, G2 plus P2 into C2. Similarly, the C4, G3 plus P3 into C3. Now, if you see all the equations, the C1, C2, C3 and C4, after evaluating, if you see C2, it is nothing but Z1 plus P1 into C1, as the C1 is already evaluated earlier. So the C1, if you substitute, we will be getting Z1 plus P1 plus Z0 plus P0 into C0. And if you observe this carry, it is quite understandable that Z1, it is nothing but it is dependent on the inputs that we apply. Similarly, Z0 is again it is with respect to the inputs. Similarly P1 is nothing but it is again with respect to the inputs. So a C0 is nothing but C in, that is the carry in that we apply. So if you observe the second C2, it is all dependent on the inputs as well as the input carry. Similarly, if you see C3, it is Z2 plus P2 plus C2. C2 is already evaluated, and if you observe C2 and substituting C2 in this equation, it will produce this equation. And if you observe this equation, all Z, P as well as C0, which is nothing but C in, this third carry is dependent only on the inputs that we have applied A as well as B, and the carry in C in or else C0. Similarly, the final C4, which is nothing but the C out, the final carry of the adder, 4-bit adder, that is C out. If you observe, it is Z3 plus P3 plus C3. The C3 it was already evaluated, so substituting that, this is the final equation we will be getting. Now in this equation, if you observe, all are in terms of Z as well as P. G and P, that is generate as well as propagate. It is only in terms of the inputs that we apply. And similarly, the last one is the C0, which is the input carry that we apply. Now if you observe this final C out, the final C out is only dependent on the inputs that we have applied to the adder, that is A, B as well as C in. So that is the reason the delay of this one will be very less compared to the ripple carry adder. So this is the 4-bit carry lookup adder. So as already seen in the earlier slide, so G is nothing but A and B, P is nothing but A XOR B. So the same thing, Z is nothing but A and B, and P is nothing but A XOR B. So similarly, all P3, Z3, P2, Z2, P1, Z1, P0, they are all the logic diagram of that one is given, and this is given as the input to the carry lookup adder generator. So that will produce C1, C2, C3 as well as the C4. C4 is nothing but the final carry. So after getting the final carry, the only thing that is remaining is the sum, that is S0, S1, S2, S3. As the propagate is already A XOR B, the final sum equation is nothing but A XOR sum is A XOR B XOR C. So as A XOR B is already P, it is nothing but P XOR C. So that is the reason for each bit P0 XOR C0, that is the first one. Next P1 XOR C1, P2 XOR C2, P3 XOR C3 will give us the final sum. So sum as well as the carry will be produced. So the advantages, it generates carry in for each full adder simultaneously. That is the main advantage of this one. That is the reason why the delay is drastically reduced. So which causes the propagation delay to be reduced. The next one, that is a VHDL program. So for this 4-bit carry lookup adder in the data flow style, the VHDL program for this one. So starting with library IEEE. Next one is the packages, that is std_logic1164.all as well as arithmetic.all. So as the arithmetic operations are required. Next one, so a VHDL program consists of an entity as well as the architecture. So entity, that is CLA for a carry lookup adder. Next one is port. So what are the inputs? Inputs is A, B. So this A and B both are of 4-bit. So in std underscore logic underscore vector 3 down to 0. So A and B both are 4-bit. So it is given as a vector from 3 down to 0. Similar to this other one, that is C in. It is a single bit. So in std underscore logic. Similarly the output. Output, it is sum. Sum is the 4-bit. So sum out std underscore logic underscore vector 3 down to 0. And finally, there's one thing that is a carry. So carry, it is a single bit. So C out is a std underscore logic type. And finally, end. So this is the entity declaration. That is whatever the interface ports that the CLA communicates, so that were listed in the entity declaration. And the next one is the architecture body. In the body, we'll write for the carry look ahead adder. So the architecture, so architecture space architecture name. So we'll write in our data flow style. So DL of CLA is. Next, so starting with begin. Next one is process. Next one, next, so directly we can write, so it is C of 0 is nothing but what? C in. So C of 0, that is C in, is directly given to the C naught. Next one is C1. C1, if you observe from the equation, it is nothing but Z naught and P naught, or Z naught or P naught and C naught. C naught is nothing but again C in. So as C1 is nothing but Z naught or P naught and C naught. For C naught, it is directly C in. Next, for C1, it is nothing but Z naught or P naught and C naught. C naught is nothing but C in. That is for the C1. In a similarly, C2. In the C2, so C2, it is Z1 or P1 Z naught or P1 P naught, P1 and P naught and C naught. The same thing. So for Z2, C2, it is Z1 or P1 and Z naught. Similarly, or P1 and P naught and C of 0. That is for the C2. Similarly, for C3. For the C3, it is Z of 2 or P of 2 and Z of 1. Next one, or Z of 2 and P of 2, or Z1 plus P2 P1 into Z naught or P2 P1 C naught. P of Z of 2 or P of 2 and Z of 1 or P of 2 and P of 1 and Z of naught, or next one is P of 2 and P of 1 and P of 0 and C in. That is for the C3. And finally the C out. Z of 3 or the equation that was already given, Z of 3, G of 3, Z2, P3, P2 into Z1, P3, P2, Z1, Z0, and this one. P of 3 and Z of 2 or P of 3 and Z of 1 or P of 3 and P of 1 and Z of 0 or P of 3 and P of 2 and P of 1 and P of 0 and C in. So finally and the architecture name that was given. So, data flow of carry look ahead adder is. Next one is begin. So this is the VHDL modeling for a carry look ahead adder. Thank you.